So next, what we would like to do is we would like to understand what the geometry of complex numbers looks like. Right? And if you think about geometry for a second, the first thing we would like to understand when we start talking about geometry, once we know how to represent things, is how to talk about distances, right? So the first question here is the following. How could one use the modulus of complex numbers to determine distances between complex numbers z and w? All right, so remember, if I give you any complex number z here, the modulus of z, as we talked about in our class, is that the modulus of z gives us the distance between z and the origin. So, but now what we would like to do is we would like to understand, is there any way we can use modulus to describe the distance between two complex numbers, not just the origin, but between two complex numbers? All right, so let's investigate this a little further. Let's say z we're going to denote by x plus iy, and w is equal to u plus iv. Right, so let me just erase this picture here and draw another picture. So let's say I have z is here, which is x plus iy, and for convenience, let's say w is right here, which is u plus iv. And so now, do we know how to find the distance between z and w? Right, so again, right now, let's say I want to find the distance between w and c. Remember, these complex numbers can be represented by a pair of real numbers x, y, and u, v. Do we know how to find the distance between 2 points on a real plane? The answer is yes, and the answer is given by the distance formula, right? So the distance formula tells us that the distance between w and z is going to be, well, you take the difference in the x coordinate, square it, plus the difference in y coordinates, v minus y, square it, add them together, put them inside the square root. All right, so now that's the distance. Again, the question is, we want to relate the distance to the modulus, right? So if I stare at this thing long enough, can I write this quantity as a modulus of a complex number? And the answer is yes, I can, right? I can view this as the modulus of u minus x plus I v minus y. And so if I take that number there, and if I take the modulus, I'm going to take the real part, u minus x squared, plus the imaginary part, v minus y squared, add them together. And now, if I squint at this hard enough, I can see that that's exactly the difference, w minus c. All right, so in some short, what we've just shown is that if we want to find the distance between two complex numbers, just take the difference of those and find the modulus. All right, so now, equipped with that, we're going to look at a few examples here. So starting with this question here, what we would like to do is we would like to describe the line segment joining z is equal to 3 and z is equal to I. Right, so let's say we don't know much about anything. What I'm going to do is I'm going to go ahead and I'm going to sketch z is equal to 3. So z is equal to 3 would be somewhere around here, and z is equal to I be somewhere around here. So the line in question is right there. So the line segment would be right there, right? So that piece right there is the line segment. And if we have this thing here, well, this is 3, 0, this is 0, 1. So I can figure out the slope, right? So the slope in this when x increases by 3, y is decreasing by 1, so the slope is going to be negative 1/3, and the intercept here, b, is 1. So I can write y is equal to mx plus b, so I'm going to get negative 1/3 x plus 1. And we can do that. So that's one way of doing it. However, what we would like to do is we would like to be somewhat smarter about doing this. And here's what we're going to do. So here's the notation that we're going to use. So if I have z and w, if I put it in interval form, that's going to describe a line segment joining z and w, is going to be given by all points that satisfy the following equation. If I take 1 minus t times z plus t times w, where t is between 0 and 1. Alright, so this is going to be a line segment with endpoints z and w. Alright, so you should be able to convince yourself that this is a line, right? So this is a parametric representation of a line from Calc 2. Oops. Alright, so this is a parametric representation. And now, what are the starting points? Well, when t is equal to 0, what happens here? When t is equal to 0, I get 1 minus 0z, which means I'm going to be at z. And when t is equal to 1, I get 0z plus 1w, which means I'm at w. So this thing here is going to represent a line that starts at z and ends at w. Right, so this is a nice representation for a line segment. Right, so next question is, let's say we know that's a line segment starting at z and ending at w. But if we did not care about the segment itself, but rather we're just looking for the line through point z equals 3 and z equals I, can we use the same information that we have to describe the line? Well, the answer is yes, right? As soon as we remove this restriction here, we're going to get a line that we know passes through z and w. And as soon as it's a line passing through z and w, there's only one, so that's the unique one. So if we lift this restriction here, we are going to get a line. And so again, it's nice to have this representation for the line segment. So again, this interval notation here is going to represent a line segment passing through z and w, or a line segment with endpoints z and w. Right, so this is, again, there's going to be multiple descriptions, but this is going to be a convenient description for that.